Hi there, I'm Alexander Younger, and this is my 1976 182P on Whipline amphibs. I'm excited today because I'm going to try out the PowerFlow tuned exhaust system and see what the difference it makes on an airplane. And listen, we all know more power is better, but especially when you're on amphibs on a hot day. So quickly about the airplane. This airplane has a Texas Skyways 0520, which is good for 285 horsepower. It was just overhauled. It's broken in. It has 50 hours on it now, so it's a great time to compare exhaust systems. It has a full Garmin suite in it now, brand new, so great data collection. It's on Whipline 3000s, and it also has a Robertson STOL kit, wing extensions, and VGs. So let's go flying it now. We're going to try it on the runway and see what its performance is like, and we'll also do some water takeoffs and landings. And we'll measure what it's like before we bolt on the new exhaust. So follow along with me and I will show you in deep detail the difference a tuned exhaust system can make.
Okay, so the first step is to get some benchmark flight data with the factory exhaust, so then I can run the same tests after the team at PowerFlow install their new tuned exhaust system. So I'm taking it up on the amphibs and I'll record the engine temps, fuel burn, speeds, climb, all kinds of stuff. I'm not going to recite all the data here, but if you want to read it, you'll find a link in the comments below. And soon enough, the big day comes. One January morning in the middle of a cold Canadian winter, I flew the 182 south so that PowerFlow could work their magic. The good news for me is PowerFlow is based in sunny Daytona Beach. Nowhere better to hang out for a few days and take in the local sights.
Darren, what are we about to do to my 182?
We are going to be removing the cowling and the exhaust system, and we're going to be replacing that with the PowerFlow tuned exhaust system.
Hi, Alex. Jim Schaefer,
Hey.
also with PowerFlow. Glad to see you down here in sunny Daytona.
Thanks for having me down. This is great.
Good. A lot of questions we get asked at the air shows is exactly how does it work and why is a PowerFlow so much better than the stock exhaust. If you look at this, you've got 3 cylinders on this side emptying into this side of the muffler. You got an identical 3 cylinders on the other side emptying into that side of the same muffler. So you have 6 streams of exhaust gas coming out of the engine, and there's only one good way for that gas to come out of the muffler. That's the tailpipe. So the laws of physics being what they are, the 6 streams can flow gas into that can faster than the one tailpipe can let it go out. And what happens is the exhaust gases build up inside the can, the pressure, and the gas actually flows back up the riser pipes. So when the exhaust valve opens, the piston's trying to push the gas out of the cylinder, but it runs into this high pressure barrier. And when we did our proof of concept testing back in 1999, we actually calculated there's 20% residual gas left inside that cylinder that couldn't get out past that high pressure barrier.
Wow.
That much.
That's a lot.
That's a lot for an engine of this size.
Okay, so now we know why the stock exhaust has so many limitations. Let's go and do a solid test flight. PowerFlow has a very specific and detailed flight test profile that we flew for all the before and afters. This tested the performance of the airplane at multiple altitudes from 1,000 feet to 8,500 feet. It not only tested for speeds, fuel burn, and temperatures, but also for climb performance. We'll show you the results after we show you what the installation of the PowerFlow exhaust looks like.
So with the tuned exhaust, there's 2 big advantages. Number 1, there is no common collection point. There's 3 cylinders on one side, but they're all spaced evenly, so the exhaust flows continuously. There's no backup point.
So the pipes are all, because this is all different length pipe, right?
Exactly.
So your system has all equal length
All
pipe.
equal length pipes. So it's a momentum of gases all flowing in the same direction. There's no back pressure. That's part number 1. Part number 2, those pipes the length is calculated. So when the first pulse comes out of, say, cylinder number 1, and it's going down the pipe, that pulse is still traveling down the pipe when the exhaust valve opens a second time. But now instead of that high pressure barrier that was there before, you have a low pressure slipstream, a wake, a vacuum, and it actually extracts the gas out of the cylinder. So when we did that same proof of concept testing, we found out instead of the 20% residual gas, there's 2% residual gas
Wow.
left inside the cylinder.
That's a huge change.
We just picked up 18%.
Yeah.
But all we're doing really is letting the engine run the way it wants to run to begin with. We're not putting any additional stresses. We're actually reducing stresses because the CHTs are going to come down by 15 to 20 degrees because the engine isn't working against itself.
So out with the old factory exhaust system and in with the new. Okay, look at this. The exhaust system is on here just a day later. We were flying a day ago yesterday doing all the test data for the before. But look how pretty this looks. I mean, not only is it an amazing exhaust system that's going to give us more efficiency, which I can't wait to see, but it looks great and it's easy maintenance, etc. So all I can say is let's get the cowls back on and let's get this thing in the air and see what it does.
This is the moment I've been waiting literally years for. When we talked 10, 15 years ago about an exhaust for this airplane.
Yes, this is true.
Already I love the exhaust sound.
Yep.
It feels like we're on a great motorcycle or something. Nice and smooth though.
The air or the engine?
The engine.
To accurately compare the before and after, we flew the same flight profile from 1,500 feet up to 8,500 feet. The Garmin's recorded all the data, and here's what we found out. We flew on days with very similar conditions, and the only real difference was the before flight had a slightly higher altimeter setting of 30.27 versus 3002 on the after flight. So here's what the airplane did. Setting the autopilot to climb at best rate of 77 knots, it climbed faster to 8,500 feet in 7 minutes and 40 seconds versus 8 minutes and 10 seconds, shaving exactly 30 seconds off the climb. The engine also produced more power, especially at altitudes of 5,000 feet and above, showing about 1.5 to 2 inches more manifold pressure. This made the airplane climb a bit faster, obviously, and we saw climb speeds typically of 50 to 100 feet per minute better. And the best part was, at altitude, the cylinder head temperatures were typically much cooler, about 15 to 20 degrees cooler, and the highest temperature on any cylinder during the climb was 362 degrees versus 389 degrees with the stock exhaust. What a difference.
Okay, we're back in Collingwood with the 182 on wheels and the power flow.
Now we just have to put the amphibs back on and do the final test.
Alex, on floats, what are the deciding factors for you whether or not any particular upgrade is worth the money that you're considering to spend to get it?
The key things any float flyer will tell you is getting off the water as quickly as you can, keeping your engine temperatures low, especially in climb on a hot day, and then also being able to run the engine efficiently, i.e. lean a peak ideally, so that you can go as far as you like without having to ferry so much fuel. Because a lot of times where we're going is we're going into remote lakes and we have to come back. There's not a lot of fuel. So
Not
you
a lot
gotta
of fuel
really,
stops en route.
you got to really plan your fuel. So this airplane hasn't changed configuration except for the power flow, but I'm seeing some significant changes for the positive, and I'm really impressed. Number one, the engine is running much cooler. It's able to extract a lot of the heat out of the engine much better. So on takeoff on a hot day like today, I'm not worried at all about engine temps. I can climb out at best rate, which is about 77 knots, no problem, and I'm getting better numbers. So where I might be squeaking sort of 300-400 feet per minute, I'm getting 500-600, which is everything you need because there's a lot of trees around and you want to make sure you're getting off quickly. But then just generally, I'm finding when I'm up, that engine is much happier. It's cooler, it's smoother, it's running better in terms of the fuel seems to be getting better distributed. I know we're talking about an exhaust system, but before I used to have certain cylinders that were much hotter and cooler than others. Like my number 6 was off the bottom. Now all of them are running much more evenly, so I know I'm getting more power out of the engine because all of the cylinders are producing better power. It's really impressive. I gotta say, it's a big change. I did not expect an exhaust system could give this much more performance improvement.
The bottom line with this new system is I don't worry about temperature anymore, which is unbelievable.
Okay, well, Alex, man, I got to thank you an awful lot.
No, I gotta
I
thank
knew
you.
I knew it was going to be fun, but it was such a thrill. That's actually, for me, one of the benefits of working for PowerFlow. I get to meet great people and go fly fun airplanes. So for me, it's like paying a kid to go to Disneyland. Doesn't get much better. So thank you very much, sir. Appreciate it.
Thank you, and thank you guys for making such a great product. It is noticeably different in all the right ways.